Hi, my name is David, and welcome to my STEM portfolio. For my first project, I was very interested in how maglev trains move, and I wanted to put my own twist onto it by making one that works in two dimensions instead of one. I started experimenting with some electromagnets that push and pull a bar magnet attached to a cart. But I quickly realized it doesn't work with simply manual timing because it'd be misaligned way too easily. For positional feedback, I tried camera tracking, but it was way too slow. My next hope is Hall effect sensors, which was a lot faster. And in a grid, theoretically they can all sense the magnetic field of the cart and triangulate its position. Because the magnets and sensors are so close, I worked out the exact equation of the cart's magnetic field with my math teacher's help, and I simulated its interactions with the electromagnet using FEMM. It actually matched up with reality surprisingly well. But getting from theory to actual smooth control was not easy. For the hardware, I swapped out my Arduino to a way faster XDM microcontroller and condensed everything to PCBs. And it took me 3 iterations to iron out all the random wiring and clearance mistakes. And for software, I wrestled a lot with glitches and race conditions. In my final version, I made these modules fully able to communicate with each other and tile together indefinitely. I built a 4x3 prototype, with the help of my little brother, of course. As I tried to make it more stable, my cart design changed a lot too. And what finally made it not so wobbly was a control loop that independently controls the 3 degrees of freedom inspired by a rocketry paper. Here it is, my prototype actually working. Later, I published this project in the IEEE Access Magnetics Journal. For my second project, I explored analog computing by adapting transistor switching behavior for matrix multiplication to run AI models. I started by testing my concept from breadboard to PCBs, and I slowly ironed out weird noise issues, and it actually works. I then began building and simulating these as a chip with K-layout and magic. It was a completely different realm, and I dealt with even more weird things like coupling issues. Now, finally, I submitted my chip design to Tiny Tape Out, and I am eagerly waiting. And for my third project, the Ham Radio Club had the idea to radio call Dr. Michael Barrett, a Camasonian local who just went up to the ISS. After we somehow got approved through the ARIS program, we needed to build a rotator to point our antenna that we already had straight at the ISS. Using whatever material we can find, like PVC pipes, extrusions, and steppers, as well as open source resources, we cobbled it together. Here we are testing it in my backyard. This was me setting up the tracking on the day of the contact, and this was us when we actually made contact. And here's a few extra smaller projects. This was a DIY AM transmitter from basic electrical components. This was a Thor's hammer that I made at my machining apprenticeship out of steel and brass. This was a RC water sampling boat I made for Lacamas Lake Watershed Council. And I know the topics are a little scattered, but I really enjoyed exploring through all these different disciplines and applications of engineering throughout high school. And yeah, thank you for watching this slice of my life.